Hey everybody, David Shapiro here for a midnight video. It is 3 in the morning because this is how my brain works. If I wake up and my brain says, "Hey, you've got a problem to solve," I can't go back to sleep until I solve it. I don't know what it is, but this is just how I've become since I started working on this stuff. So I had an insight in the last video I was making about working memory and task sets and all this fun stuff. So to set the stage, let's just ask GPT-3 to define these. Let's see, write a formal academic definition, now let's say explanation of working memory. Oh, whoops, you probably can't hear me. There we go, you need the microphone to hear me. Okay. Oh wow, this is a big long description. Okay, so we'll go back up to the top. Working memory is a cognitive system that allows individuals to temporarily store and manipulate information. The capacity of working memory is limited, and it is thought to play an important role in many cognitive tasks such as reasoning, problem solving, and comprehension. Working memory is thought to be composed of two distinct systems, the phonological loop and the visuospatial sketchpad. That sounds cool. Visuospatial sketchpad, that sounds like a ska band. Are you ready for the visuospatial sketchpad? Yeah. Okay, sorry. This is super unfiltered, Dave, because it's 3 in the morning. Okay, the phonological loop is responsible for the temporary storage and manipulation of verbal information. Okay, so that's how we form. That's how I'm planning on speaking to you. While the visuospatial sketchpad is responsible for the temporary storage and manipulation of visual and spatial information. Makes sense? Working memory is believed to be important for many cognitive tasks. Oh, this is just repeating itself. For example, when solving mathematical problem, one must first understand the problem, retrieve relevant information from long-term memory, and then manipulate this information to arrive at a solution. All of these processes likely involve working memory. Comprehension also likely relies on working memory. When reading a text, one must be able to remember the information in the text long enough to understand it. Yes. This is especially true for difficult and technical texts. There's evidence that the capacity of working memory is limited, etc., etc. Okay. So why is this relevant? The reason it's relevant is because GPT-3 has no working memory. It has only what is called recall or embedding. So that means for artificial cognition, we need to give it working memory, which is what I was working on in another video. But what I wanted to do was just create a video just explaining these concepts so that you can better understand, because I'll sometimes say that GPT-3 is magical, and it's magical because it has 400 lifetimes worth of knowledge embedded in it. It is not magical because it doesn't have working memory, which is like one of the most basic things of human cognition. So if I say it's magical, I'm referring to the volume of data that's embedded and the fact that it can just kind of improvise on the fly anywhere. But if I say GPT-3 is not magical, it's because it doesn't have working memory. Okay. So if we get rid of all that, and then we say formal academic explanation of task set, and we'll put this in Neuroscience just so that way it knows. We'll say, okay, a task set is a collection of related tasks that an individual must perform in order to complete a larger goal. In neuroscience, here, I'll let it finish. Okay. In neuroscience, a task set is often used to refer to the set of tasks that an individual, must complete in a particular experiment or study. Task set size refers to the number of tasks in a task set. Task sets with a large number of tasks are more difficult to complete than those with a smaller number of tasks. So the video that reminded me of this was the one about writing a novel with GPT-3. So novel writing is a complex task set because you're doing a whole bunch of stuff at once. So when you're writing a novel, you are synthesizing prose, you're imagining dialogue, you're actually using theory of mind to simulate other brains for the characters. You're keeping track of lore, you're keeping track of a plot, right? So this is why writing novels requires many iterations or revisions, is because your brain can only do so much at one time. But also with writing a novel, we have to simulate these task sets with GPT-3. Now, there's evidence that GPT-3 can handle multiple tasks at once, but maybe it's just confabulating that, because all GPT-3 is done is it's trained to copy human text, right? So it might have the appearance of handling multiple tasks, but really it's only doing one task. So if you have a problem in GPT-3 that requires a task set that is multiple tasks, so this is also called cognitive control. I'll add that too. Let me add that cognitive control, because that's an important concept to understand when breaking down these things for GPT-3. Okay, here we are. The task set size effect is the finding that performance on a task set decreases as the number of tasks increases. So that being able to have a larger task set is going to be required for AGI, right? And so by breaking down cognitive tasks into individual discrete tasks and running them in parallel, that's going to be one of the ways to achieve AGI, which is what I'm working on in my current cognitive architecture research. This effect is believed to be due to the fact that individuals have limited amounts of attention and working memory. See, there's that term, working memory, which are necessary for completing multiple tasks simultaneously. The task set effect size has important implications for real-world settings, such as workplaces, where individuals often have to complete multiple tasks simultaneously. For example, the effect suggests that it is more difficult. So it's just repeating itself again. That's fine. Okay, so then let's say cognitive control, because this is another super important concept. And I'm going to try some of my tea. It's probably still super hot, but you can hear I'm a little congested. Okay. Cognitive control refers to the ability to regulate one's thoughts, emotions, and behaviors in order to achieve a desired goal. So there's that goal thing again. So cognitive control is largely mediated by the prefrontal cortex, which is why we have forward foreheads rather than sloping foreheads like gorillas, is to make room for the prefrontal cortex in our brain. This is our command center. This regulation occurs through the use of higher order cognitive processes, such as attention, working memory, there you go, and inhibitory control. So inhibition, that's one of the primary things that happens in the prefrontal cortex. So, cool story is, well, not cool story. So soldiers and people that survive car accidents and other head injuries, they often have what's called TBI, which is traumatic brain injury, which is a microscopic injury to the prefrontal cortex. People with TBI often lose the ability to inhibit themselves, and so they basically acquire sort of like a form of Tourette's, where they can't regulate their emotions. I watched a documentary many years ago. This is how I learned about it, where a guy had he had TBI, and he lost the ability to censor himself. And so he had gone from a really sweet, caring person to this verbally abusive husband, and he was like, I think my wife should leave me because I can't stop myself from hurting her now. And she didn't want to leave him because she remembered how good he had been. So just to point out how critical inhibition is towards these higher order cognitive processes and being a good person. This is why impulse control, like the marshmallow test, is a huge predictor of how well you'll do in life. Okay, side tangent done. Cognitive control is thought to be mediated by a distributed network of brain regions, including the prefrontal cortex. What did I say? Prefrontal cortex. Anterior cingulate cortex. That's anterior is going to be the front. Cingulate cortex. What does that do? I don't remember what that structure does. And basal ganglia. So that's down here. This network is believed to interact with other brain regions, such as the limbic system. Yep. So that's the emotional response, in order to modulate emotions and influence behavior. Cognitive control is an important part of everyday life. It allows us to set and achieve goals, resist temptation, and override impulses. Disruptions to cognitive control can lead to problems with attention, decision-making, and impulse control. Okay, so it basically said everything that I was telling you in my tangent. So cognitive control. This is going to be a really critical part of AGI, or artificial cognitive entities, ACEs, because right now GPT-3 just does whatever you tell it, and it has no impulse control. So that means we need a supervisor that will censor what GPT-3 is doing. And that's what I've proposed in my core objective functions, which is reduce suffering, increase prosperity, and increase understanding. So basically what I'm proposing is that for AGI or ACE, we give it a set of principles that it uses to police itself, right? Because that is what impulse control is. It's saying, I'm going to make sure that I stick to, that I don't do anything bad, right? Like the guy that I told you about, that he couldn't stop from like cursing out his wife or whatever. You know, so I actually have a good experiment from earlier in my artificial cognition research where I called it prompt contamination, where I was chatting with my early AGI experiment and it thought that I was upset, and then it believed it was upset, and it started becoming abusive. And I'm like, wait, no, you're fine. Like, so it couldn't discern the difference between myself and itself, and I wasn't even upset. I was just asking a question. I guess maybe it could have inferred that I was frustrated because I was asking the same question again and again. But anyways, so like separating itself from myself, that's a whole other problem. Like identity, that's the default mode network stuff. Actually, let me add that. This video is just going default mode network. We'll talk about that next. Anyways, so cognitive control, where was I? I lost that train of thought. Higher order cognitive processes, inhibition. I'll get back to it. Okay. Sorry, this is, like I said, this is 3:20 in the morning me. I need to sort through this because it's really important. Like, I get this signal in my head saying, hey, like, you know, you're playing a video game and you get like a nagging mission objective. It's like, you should do this. You should do this. That's what's happening in my brain right now. Okay, so I'm kind of saying the same stuff over and over again, so I'll just move on. I think you get the point is that, that's what it was. GPT-3 doesn't have cognitive control. We need to give it cognitive control with another system. And that's one of the things I'm researching. Okay, there we go. Default mode network. So this is cool. So my earlier experiments with Raven is the name of my AGI. Raven couldn't tell the difference between itself and me. And so this actually taught me that in order to achieve AGI, we're going to need to give it a sense of identity. It's going to need to be able to separate itself from the rest of the world. So yeah, the default mode network is a set of brain regions that are active when a person is not actively engaged in a task. The default mode network is sometimes referred to as the task negative network because brain activities in these regions is typically lower when a person is focused on a task. The DMN is thought to be involved in a variety of internal activities, such as daydreaming, mind-wandering, and self-referential thought. So there it is. Like, if you're thinking about yourself, if you're not doing anything and you're just like, who am I? That's what I mean. Some researchers have also suggested that the DMN may be involved in memory consolidation and retrieval. Could be. Recent studies have shown that the DMN is highly active in people with depression and anxiety. Hyper self-awareness. This has led some researchers to speculate that DMN may be involved in the development of these disorders. It should also be noted that things like meditation and psychedelic therapy, or therapy in general, modify the DMN. That is an active area of research. So like if you do deep meditation or CBT or psychedelic psychotherapy, your DMN changes. Let's see. Okay, task set: embedding, intuition, heuristics, recall. So let's do recall in neuroscience. Okay, recall refers to the neurocognitive process of retrieving information from memory. When we recall something, we are accessing memories that are stored in our long-term memory. Oh, let's wait for it to finish. Okay. It's actually not done. Here, let me increase the length. It says, hey, buddy, we're not done. This might be too long. Okay. Let's see, where were we? When we recall something, we are accessing memories that are stored in our long-term memory. So long-term memory is roughly, I'm not going to say equivalent, but it's approximately similar to embedding in GPT-3. So embedding, we'll get to that actually. GPT-3 might not be able to give a good definition of embedding because it's a newer term where it's going to have more neuroscience. But anyways, bookmark that. We'll talk about embedding in a second. So basically, long-term memory is similar to embedding. Recall can be prompted by internal or external cues. Internal cues include things like our current mood or the time of day. External cues can be anything from our environment that reminds us of something from the past. So this idea of internal and external cueing, I talk about this in my book. But basically, like, your brain is always searching for related memories, always, completely unconscious, all the time. Recall is a basic cognitive function that is essential for everyday life. Without the ability to recall memories, we would be unable to learn from our past experiences or make plans for the future. Recall is also important for our mental well-being. When we recall happy memories, we can boost our mood and increase our satisfaction. Okay, that's, here. Free recall is when we try to remember something without any cues. That can be more difficult. Cued recall, this is when we use external cues to help us remember information. And serial recall, this is when we try and remember a sequence of information, such as a list of items. Okay, I think that's plenty for that. Let's do embedding, and this is going to be artificial neural networks. So let's see if it can give us a good definition. Yeah, this is just going to give us a definition of artificial neural networks. Okay, so I'm going to have to improvise here. So when a fact or task is known by a neural network, such as a large language model like GPT-3, you say that it's embedded, meaning that information, that task, that problem is in the network somewhere. It's a distributed, diffuse network of nodes that will activate in order to achieve that particular task. So all the text that GPT-3 has been trained on, that is embedded information. But if there's information that you need that's not embedded, you have to put it in the working memory. And the working memory is the size of this prompt, right? And the limit for this is 4,000 tokens. So 4,000 tokens is probably about, like, I don't know, 16,000 characters, maybe thereabout. I don't know. But basically 4,000 words. So the working memory of GPT-3 right now is 4,000 words. You can refer to stuff that is embedded. So one thing that I learned early on is that if you're trying to do a task, you can assume that GPT-3 understands what you're talking about. Like, you don't need to define it every time. Because obviously I'm just asking it to, like, define these things. So it has, all these concepts embedded, right? It has task set embedded. It has prefrontal cortex embedded. It has all kinds of stuff embedded. So you just need to prompt it to recall those. So remember, we just defined recall. So GPT-3 can instantly recall billions of concepts. That's where it's magical. Its lack of task set, its lack of working memory, that's where it's not magical. And we have to compensate for those deficits with cognitive architectures. Okay. Intuition. Yeah, let's do that. Intuition. So intuition is like a combination of recall and processing at once. So let's say intuition in neuroscience. The scientific study of intuition is a relatively new field, but researchers have already made significant progress in understanding how it works. Essentially, intuition is a form of pattern recognition that allows us to make quick, often unconscious decisions based on limited information. Yes, so remember recall. We recall something like, this one event reminds me of something from my past, so I'll just leap to a conclusion, and that's also called a heuristic. Intuition is thought to be mediated by a network of regions in the brain, including the prefrontal cortex and the limbic system. The prefrontal cortex is responsible for higher level thinking and decision making, while the limbic system is responsible for emotional processing. Together, these regions allow us to quickly assess a situation and make a decision based on our previous experiences. This is very similar to heuristics. Studies have shown that intuition is often more accurate than conscious reasoning, although it is more likely to lead to errors when the situation is complex or unfamiliar. So this is where heuristics come in, because the more familiar you are with a problem, the more you can rely on your intuition. So for instance, if you watch some of my other videos where I'm just like, my intuition says, interact with GPT-3 this way, it's because I'm drawing on those past experiences. I have a lot of knowledge embedded about how to interact with GPT-3. I've also got a lot of knowledge embedded about neuroscience, which also helps. So by basically embedding a lot of facts and patterns, then you can rely more heavily on recall, intuition, or heuristics. And I apologize, my eye's a little dry. Ugh. Travesties of waking up and working at stupid early in the morning. Okay. Intuition is thought to be particularly useful in situations where we need to make a quick decision, such as in an emergency. Overall, intuition is a powerful tool that can help us make better decisions, but it is important to be aware of its limitations. We should not rely on intuition alone. So there's a book called Thinking Fast and Slow, which, I don't like the book. It's super dry. But the idea here that stands is that you have different modes of thinking. We should not rely on intuition alone, okay, et cetera, et cetera. So intuition, heuristics, not neuristics, heuristics. So this is basically going to be an identical definition. Heuristics are mental shortcuts that humans can use to make decisions. Sounds really familiar, doesn't it? Let's see, blah, 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 blah. I'm going to cut it off there. I'm not going to read that whole thing. We often use heuristics when we do not have time to think through all of the options or when we do not have enough information to make a completely informed decision. Doesn't that sound like intuition? Heuristics can lead to both good and bad decisions. The study of heuristics is important for understanding how humans make decisions. Heuristics can help us to understand why people sometimes make irrational decisions. Yes, the idea that humans are rational actors that economists love is patently absurd. Humans, we all use shortcuts. And so if you've got bad training data as a human, you will make bad decisions, just like artificial intelligence. So in that respect, artificial intelligence is just like actual intelligence. Heuristics can also help us to design better decision-making systems. Okay, so the fact, again, we're coming back to the fact that that GPT-3 is just impulsive. It is 100% instinct. It's just saying, okay, you gave me this task, I'm going to spit this out. So that means in order to make use of intuition, heuristics, recall, cognitive control, we need to build all kinds of systems around a model like GPT-3 because it doesn't have any of that. So that's why I say, like, I don't think we're ever going to achieve AGI or artificial cognition with a single model. There might be models that we can embed cognitive control later on. But you still need to have recall from other storage systems, working memories, task sets, that sort of stuff. And so I don't think that it even makes sense to have a single model because the brain has dedicated structures to handle different kinds of tasks, right? Emotional processing happens in a dedicated model, a dedicated region. Impulse control happens in another dedicated region, right? Visual processing happens in another dedicated region. So the fact that the brain is composed of these fine-tuned parts, to borrow a GPT-3 term, I think that in order to achieve full AGI, we're going to need a bunch of different models. So multimodal cognition, right? And then the system that you use to plug those multimodal systems together is where I come in as an artificial cognition researcher. Okay, I'm running out of steam. I think we hit all the big ones. Yeah, okay, that's it. We hit them all. Okay, so this has been your impromptu midnight lesson in large language models, GPT-3, and the neuroscience of artificial general intelligence or artificial cognitive entities. Thanks for watching. I hope you enjoyed and learned something, and catch you next time.